So properties of sound waves. Here are the learning goals. Calculating the speed of sound as temperature varies in its environment. We want to define the Mach value and its relation to sound. Discuss sound intensity and area of dangers to the human ear. So look at this. We have a V sound. Velocity of the sound is 332 meter per second plus 0.6 meter per second in Celsius multiplied by temperature. If you have temperature, put that in equation, let's say 20 degree. Put it here, you will get the velocity of sound at that temperature. So of course, the warmer the atmosphere, so you have a higher temperature, the velocity will be higher, right? Temperature increases, speed of particle increases, and the transmission is uh, faster because it's transfer sound faster. Any question? Here the temperature is in Celsius. Now here's an example. What's the speed of sound in air when the temperature is 25? Simply, we'll say if the velocity is 330, I think 31, right? 32. 32 plus 0.6 multiplied by temperature in Celsius. You do that, you get the answer versus the velocity 332 plus 0.6 multiplied by -10. It's going to be 332 minus 6. So that would be 12 to 326 meter per second. Okay. Also, you can calculate that. Now, when an object travels close or faster than the speed of sound, we refer this speed as Mach numbers rather than meter per second. So Mach 1 represents traveling as the speed of sound. Also, if you are traveling greater than Mach 1, it is supersonic. Below Mach 1 is subsonic, and greater than Mach 5, it's hypersonic. Perhaps you have heard hypersonic jets, hypersonic kind of, or supersonic jets that they kind of break the sound barriers. If you are near those jets created by military, you will hear a very big, loud noise. And this jet trying to fly and break that sound barriers means they are going faster than the speed of sound, a little bit faster speed of sound, right? So, and is Mach, you perhaps heard it in news, right? To find the Mach number, this is what we do. Velocity of the object divided by the velocity of sound. Of course, if the velocity of the object is the same as velocity of sound, it's going to be 1. So it's going to be 1 Mach, as I said here. The velocity of the object is twice of the velocity of sound. We say 2 Mach, right? So, and so on. Here's an example. Calculate the Mach number for a human running at 18 meter per second if it is 25 centimeter outside. So first of all, we need to find the velocity of the sound when the temperature is 25. So what we do, 332 plus 0.6 multiplied by 25. It's gonna be 15. Now 15 plus 322 is 7 for 347 meter per second. And I want to find a Mach. Mach is velocity of object divided by velocity of sound. So this is the sound velocity, right? So it's going to be 18 divided by 347. I need to have some calculator to do that. Give me a second, everyone. Okay, so it's 18 divided by 347, 0.052. That is a very small number. It's not even close to 0.1, right? The Mach value of an object traveling at some unknown speed is 0.12 on a day where it is 6 degrees outside, how fast they are traveling. So I can't find the speed of sound if I have a temperature. This is something that you quickly do it. It's 332 plus 0.6 multiplied by temperature, which is 6 degrees. Quickly do that. 332 plus 0.6 multiplied by 6 is 335.6. This is the sound, the velocity of sound that you can immediately do. And you know the Mach is V of object divided by V of sound. The Mach value is given to me 0.12. Velocity of the object, I need to find it out. Velocity of the sound, I got it here, 335.6 cross multiplication. Object is just 0.12 multiplied by 335.6 multiplied by 0.12 is 40.27 meter per second. This is going to be the velocity of the object. Any question? Now here is the sound barrier. The term sound barrier is used to describe the buildup of sound waves in front of a plane that nears the speed of sound. It's kind of the one that is yours trying to break the sound barrier when some objects or the airplane going faster at speed of sound. This happened because the plane is catching up with its own jet noises. The pressure built up of the air molecules create a barrier for an object to pass the speed of sound, requiring a great deal of energy to pass the speed of sound. Right? Hope I can play that video for you. Just give me a second. So I'm going to just go through this.
All right.
Very loud noise when they try to That's amazing.
Ladies and gentlemen, the Super Hornet high-speed pass.
Okay. They're just giving you difference. When they just pass, they will just making very loud noise. So it's requiring a lot of energy to do that, or it's just breaking the sound barriers. Okay, where were we? Uh, okay, where is that? To get out here, yeah. All right. Now, next things we do is what is intensity? Now, intensity defined as a rate of power that passes through surface with an area A, perpendicular to wave's direction. So it's gonna kind of energy per or kind of power. Look at that. It's power per unit area. The unit of the intensity is water per meter square, watts per meter square. If you just look at the wave, it's gonna be a sphere, right? And just producing a sphere and it's compressing the air and pressurize this and decompress the air and it's moved forward. And you see, as it's going, moving forward, you'll see the intensity decreases. The line that you see is getting further and further. Is the area well getting bigger and bigger, right? And the power will be distributed in a bigger area, means your intensity decreased. Now, sound intensity and decibel. So we describe intensity as decibel. Looking at this, there are sound intensities. I'm going to just make it bigger a little bit. So it's just threshold is 0 is normal hearing. Go up to 30 decibel. It's kind of the noise, like a library noise. Going to the 50 decibels is a washing machine. 60 decibels, a vacuum cleaner. 80 decibels, B0 is kind of normal. Below the screen, there are um, permanent damage is negligible, right? It's noisy, but it's safe. Then 90 decibels is the right on mover. Um, it's 110 decibels. This is kind of like a noisy disco. 120 is a gunshot, and so on, right? I believe those are very harmful if you're again working in a factory with a very high noise. Just recommend you plug in an earplug, right? Make sure um, your ear not getting damaged over the time. So those are the work safety protocol that you need to follow if you're working in a very noisy factories to prevent those damages. Um, so kind of saying that exposure time before hearing damage can occur, right? Um, and these are the time damages, like for before the damage occur for the different um, sound intensity. Now, intensity and loudness. I need to connect my laptop to charger. Okay, how does the loudness of a sound comparing to intensity? So we know that the sound travels outward from the source, like a sphere, is a three-dimensional. The further it travel, the more area sound has to cover, right? So the sphere getting bigger and bigger. So the area that it need to cover is become bigger and bigger. So therefore the intensity decreasing because the denominator become bigger and bigger. Still we have the same power. This power need to distribute between the bigger area. So the intensity will decrease as R increases. Uh, so as you go further and further, that's the loudness decrease, right? That's why you are very far from a person. The loudness is very small compared when you are near the person, right? You will see a very clearly, hear that person very clearly. The distance so related to the loudness or intensity and the loudness related. More intense means very loud. Less intense means not loud. Okay, let me just online. I want to just stop this recording, I guess.